This is a problem from the JEE online exam 2018, number 71. So we have this piecewise function, and it says the value of k for which f is continuous at x equals 2 is, and then we have a couple choices. So keep in mind here, the definition of continuity, we want this function to be continuous at 2. That means that we want the limit as x approaches 2 of f of x to be equal to f of 2. That's what it means for a function to be continuous at 2. So in this case, f of 2 is simply k, because when x is equal to 2, you get k. So we want the limit to be equal to k. So all we have to do in this problem is take the limit of this and find the answer, and that will be k. So let's work it out. So we have the limit as x approaches 2 of f of x. So the question might be, well, which piece do you use? Well, when you're taking limits, you only care about what happens when x is really, really close to 2. So in particular, x is never equal to 2. So you would use the first piece. So we have x minus 1 to the 1 over 2 minus x. So whenever you have a variable to a variable power, typically what you do is you use logarithms. So what we'll do in this problem is we'll call this y. So y is equal to x minus 1 to the 1 over 2 minus x. And then we'll take the natural log of both sides. So how did I know to do that? Usually, again, when it's a variable to a variable, this is a really good strategy. So now we'll take the natural log. And here we also have the natural log. And this is 1 over 2 minus x. Then we can use properties of logs to bring this down, right? That's the power rule for logs. So this is the natural log of y equals, I'm going to write it like this, 1 over 2 minus x ln x minus 1. And again, we're taking the limit as x approaches 2. So we're going to go ahead and work through this and take the limit of this as x approaches 2. So let me go ahead and restart that. So we want the limit as x approaches 2 of the natural log of y. That's equal to the limit as x approaches 2 of the natural log of x minus 1 over 2 minus x. Once we figure this out, we can figure out the limit of y, right? This is y, right? We want to figure out what the limit is. Once we have that limit, we know it's equal to k and we're done. All right, you'll notice here, if you plug in 2, you get ln of 2 minus 1 over 2 minus 2. So you get ln of 1 over 0. So you get 0 over 0, which is undefined. So we can use L'Hopital's rule. So L'Hopital's rule says we can just take the derivative of each piece. This is equal to the limit as x approaches 2. So now we'll take the derivative of the top piece. So the derivative of ln x is 1 over x. So this is 1 over x minus 1 times the derivative of the inside function, which is 1, chain rule, all over the derivative of the bottom, which is negative 1. This is equal to the limit, going kind of fast, sorry, as x approaches 2. So the negative, you can just pull it out, so it's negative 1 over x minus 1. Now you can plug in the 2, and you drop the limit signs. This is negative 1 over 2 minus 1, so you just get negative 1. So you might say, well, that's not one of the choices. Ha! But we're not done, right? So we showed that the natural log of y, let's justify every single step, approaches negative 1 as x approaches 2. Because the exponential function is continuous, right? E to the x is continuous. That means e to the ln y approaches e to the negative 1. Well, e to the ln y is simply y. So y approaches e to the negative 1. You might say, well, what's y? Y is the original problem, right? This is our y up here. So this approaches e to the negative 1. So we showed that the limit of as x approaches 2 of y, which was our original function, x minus 1, 1 over 2 minus x, is equal to e to the negative 1. And we know that has to be equal to k. And that is the value of k, so the answer in this case is choice 3. Pretty cool problem. I hope this video has been helpful to someone out there studying for the super intense JEE exam. Pretty cool. That's it.